Thank you for having me to RAMSES. I've had a good 2 days. I've learned a lot about the medical field, and I've been surprised to see how many connections there are to education and teaching and learning. In particular, the way that you all collect data and use data to improve your practice is something we in education can really take from the medical field. So I am the middle school head at the Elizabeth Morrow School in Englewood, New Jersey. We are a 3-year-old through 8th grade school, so our oldest students are 14 years old. And we use robotics in our school to not to promote robotics or engineering per se, but really to promote learning and thinking. We are at the precipice of an interesting time in education and in the world. And in the beginning of the 20th century, we were thinking a lot about industrialization and how do we create skills for an industrialized world. And now we're thinking about a digital time. And with that, we have a couple challenges. The first of which is that knowledge is ubiquitous. At any given time, anyone can pick up a smartphone and Google and find the answers to virtually any question. And the second challenge we face is the fact that technology is extremely accessible. So 14 months old can pick up an iPhone and find YouTube and get to a game. So how do we cope with that in education? The paper and pencil test is no longer an accurate way of assessing learning because that learning is now obsolete. So we look at our 21st century skills, and the 21st century skills are creative thinking. How do we problem solve? How do we take multiple disciplines and put them together? How do we create? How do students create? How do they take that problem solving and take that knowledge that they have from Google or Wikipedia and actually do something new with it? How do students collaborate? How do they think together, work together, make room for other people's point of view, create something larger than oneself? How do they communicate? And in particular, receptive communication. So how do they communicate their own ideas, but also how do they listen to others and use that information to create a new way of thinking? And last but not least is character. And many people think of character as morality, manners, holding the door for people, doing good in the world. But character is also a disposition that has a lot to do with what you do when you face challenges. How do you persevere through difficult situations? How do you look at the world as something that you can improve as opposed to something that you take from? So we talk a lot about these skills in 21st century education, and there are a lot to think about. So when you think about the 21st century and think about the ubiquity of knowledge and the accessibility of technology, what schools are doing now is actually taking technology and going very low tech, because it's so easy and technology has almost become where skills are obsolete. We're actually taking the technology out of a lot of our science and math and engineering curricula at the very early grades. We're creating these spaces called maker spaces, which are basically open spaces with a lot of raw materials. There's a lot of cardboard in maker spaces and scissors and yarn. And we're asking students to create challenges and create new products out of these very raw materials so that they can learn how to think about how to put things together. One concept that is extremely well known in the States in particular is the idea of STEM education: science, technology, engineering, and math. And in recent years, many schools have added the A for art to that concept because we're really trying to involve the design process in when we think about science and technology and engineering and math. It's not just knowing information; it's actually doing something with that information and creating something new with that information. So when we do that with our youngest students, we teach them how to think about how to build, about how to create, about how to think about new products and new ideas for the future. So here's an example of a project at our school. We take our 8-year-olds at our school and we give them what we call the Mobile Mint Challenge. And we give them a little baggie with a bunch of raw materials, lifesavers, 2 cards, no cards, popsicle sticks, 2 straws, and a rubber band. And we ask them to create a vehicle that will roll down a slope and then continuously roll for 4 meters without being touched. And so they actually have to conceptualize a concept based on the materials and the input that they have and create something. And they usually fail, and they usually fail several times throughout the process. Here's one student who was struggling with this concept and how to work through it. Okay, the sound's not working. Okay. It is.
If you move your microphone a little bit down.
Yeah, that's a good point.
What's the problem? Oh no.
So what I love about that clip is the student is so engaged in what he's doing. He's really working through, in a relatively complex way, how to create this mobile being out of very raw materials. But then you also see all the innocence of childhood when he loses his mint. And if I had kept showing, another student would have said, "Just ask Miss Smith, she'll give you another one." And so you see how these students are really thinking, thinking about how things work, and they're not doing it with a screen in front of them, and they're not being told how to do it, and they're not doing it by simply swiping. They're actually putting these materials together. So as they get older, then they take that way of thinking, that disposition, and they actually are given the tools to actually create much more complex robots. And so I went to a local technical school in Bergen County, New Jersey, a magnet school that's highly selective, the best 16, 17, 18-year-old minds in our area of New Jersey. And they have some really complex tools. So they have an abrasive water jet machine, a mill, and a large-scale 3D printer. And these students actually are not only designing robots, but they're actually designing the parts that are creating these robots. They're thinking through what parts do they need to actually create robots to accomplish certain tasks. And so here's what they came up with in this particular design. On the left is a robot that is going to be used in a competition where students have to take rings from one area of the gymnasium and hang them at certain levels of a wall on another area of the gymnasium. And the robot that gets the most rings and hangs it highest on the wall is the one that wins. This robot on the left, every single piece of this robot was designed and created and manufactured by students. using raw tools. They were not given a kit, they were not given directions, they were simply told you're going to have to create a robot that picks up rings and hangs it up high on a wall. And they also created the circuitry to actually power the robot, and they created the code that programmed the robot so that they were able to accomplish this task. Another competition that is very popular, particularly with boys in high school, is what's called battle bots. So they create robots that actually go into a steel cage and battle other robots from other schools. And they have to think about the physics in terms of using leverage, the strength of these robots. And they compete every single year in these competitions. And this motivation is what keeps them going. They're not thinking about, are we going to create the next Da Vinci? They're thinking about, how can I win this competition? But those thinking skills carry on. So once we introduce the technology back in, the sixth C of 21st century thinking and 21st century learning is this idea of coding. And coding is really, really important in the 21st century. So I'm going to play you a clip by an MIT professor named Mitch Resnick, and he talks about coding as a language in and of itself. Could you hear that? Did they hear
that? Now maybe you won't be so surprised by this, because a lot of times people feel that young people today can do all sorts of things with technology. All of us have heard young people referred to as digital natives. But actually, I'm sort of skeptical about this term. I'm not so sure we should be thinking of young people as digital natives. When you really look at it, how is it that young people spend most of their time using new technologies? You'll often see them in situations like this, or like this. And there's no doubt that young people are very comfortable and familiar browsing and chatting and texting and gaming, but that doesn't really make you fluent. So young people today have lots of experience and lots of familiarity with interacting with new technologies, but a lot less so of creating with new technologies and expressing themselves with new technologies. It's almost as if they could read but not write with new technologies. And I'm really interested in seeing how can we help young people become fluent so they can write with new technologies. And that really means that they need to be able to write their own computer programs or code. So increasingly, people are starting to recognize the importance of learning to code.
So this is what code looks like, and this is not what that young man who was challenged with the Mint is able to access at this point. He doesn't have the math background. This is what our most advanced high school students are able to do. But we still want to introduce code and the language of code at younger grades. So there's a program called Scratch that uses block code, and each block, each line of Scratch has a certain set of variables that students are able to access and think through multi-step problems that create a little cartoon character who's able to do backflips. And then we introduce that Scratch, that block coding to this very simple tool. It's simply a ball called a Sphero ball. That can receive code and go a certain length. So in this case, it says that every time each color is representative of a line of code. So after 6 lines, it will take a 180-degree turn back, and they'll program these balls to follow these lines and go through certain challenges. And then again, as students get older, they take all these capabilities together, and we really want to put them in a position to think about real-world problems. So again, this is from Bergen Academies, the technical school I referenced earlier. On the left is a robot that is programmed to autonomously follow medics into battle, to help medics with the information they need to attend to soldiers. And on the right is a robot that is used to reflect mood for autistic students, and will reflect light back based on the feedback they're getting from the eye movement of autistic students. These are relatively crude concepts. They're not ready for the market by any means, but it's exactly how our students are thinking about how to take what they know and apply it into the real world. And so where do we go from here as educators? We have a lot of tools at our disposal. We face a lot of the same challenges you do. We need research to back up what we do. We need money in order to purchase the materials and curricula and people to put forth this curricula. And in order to get that money, we need to validate that it's going to be worthwhile. So right now there's a lack of quantitative research on the impact of robotics in education. In the States, test scores really drive everything, and test scores are really limited. They promote lower level thinking skills, and robotics promote higher level thinking skills. And so it's very hard to quantify how robotics actually improve math scores. Those of us who believe in it, believe in robotics as a teaching tool, are really challenged by this concept. There is very little curricula, so we're really talking about the talents of really motivated and passionate individual teachers who are taking robotics and bringing it to students in individual schools. But there are very few, other than the competitions I referenced, there are very few curricula that schools can adopt and put into place. And then there's the narrow use of robotics in education. Few schools do it. Those who do it very deep, but it is not something that is done broadly. And finally, girls. We are facing a real crisis in that girls do not view themselves as having the skills or dispositions to be successful in the STEM fields. And schools have studied this and are starting to understand why that is, and are really looking to find ways to incentivize girls to think of themselves as future engineers and future doctors and future mathematicians. So I will end the way I started by saying that we do not use robotics as a way to necessarily promote future engineers. We use it as a way to inspire learners, and we use it as a way to light fire under children so that they can take those skills and maybe become future engineers, maybe become future doctors, maybe become future philosophers, psychologists, teachers. But what we want is passionate people. And that's something I've seen this week. Every single one of you has really inspired me with the energy you bring to your fields, and it's been a great week, so thank you for having me.